Okay, so as you can see, all of these lines are parallel with each other. Now, looking at the equations on the left-hand side, can we work out why? Well, it's because all the gradients are the same. And when you think about it, if two lines are parallel, they're going to be the same angle to the horizontal. Basically, they're going to be the same steepness of the line. If I changed it so as it wasn't, the gradient wasn't 2, but instead 3, clearly it's not parallel anymore, or 4, or just 1, or whatever. It's not parallel. Um, so, the parallel lines are relatively easy. The gradient would be the same. Now, it doesn't matter at all what the y-intercept is, apart from if it was the same y-intercept, I suppose it would be on the same line. So, if it's got a different y-intercept, then we would say it's two different parallel lines. But if it had the same y-intercept, it'd be exactly the same equation. Now, what about if we did a perpendicular line? Let's think about a perpendicular line which would be perpendicular to all of these. If it's perpendicular to one of them, it's got to be perpendicular to all of them when you think about it. And you'll also notice that this perpendicular line has to have a negative gradient. So if this is a positive gradient, this would have to have a negative gradient. But also, so that's a start. We can see that if one line has a positive gradient, then the perpendicular line must have a negative gradient. We can also see a couple of other things. So if I were to turn off these lines, let's turn off all of them apart from that one maybe, and we'll make it a fair bit steeper, so 5x. In fact, I'm going to redraw that perpendicular line. So I guess that's probably something like that, maybe. Now, if I were to then change the steepness of this line to something like, let's say, 8x, you can see it's no longer perpendicular, which makes sense because I changed the angle of the other one, so the other angle, the other one, so I changed the angle of the red line to the pink line, can't be perpendicular anymore. So if I drew another one that's perpendicular, this one is perpendicular, and you'll notice that the second line I drew is less steep than the first line that I drew. So the steeper the first line, the less steep the other line, and it has to be the opposite sign. In other words, if this is a positive gradient, this must be a negative gradient. Again, it doesn't matter what the y-intercept would be of a perpendicular line. So, this one would be going through, looks like about, 1.2. This one will be going through about, negative 1.2 maybe. This one will be going through about negative 3.1, something like this. But it doesn't matter what the y-intercept is. With the parallel lines and with perpendicular lines, we're only interested in the gradient. The intercept makes no difference. So let's look at perpendicular lines in a little bit more detail. Okay, so here we have a load of perpendicular lines, and I've paired them up so if they're the same color, they're perpendicular. So if I were to turn off these ones, you'll see that those two red lines are perpendicular. If I just turn these blue ones on, hopefully you can see the blue ones are perpendicular. So basically, all pairs of lines are perpendicular to each other if they have the same color. Now, I realized that in order for to be perpendicular, the gradient has to be the opposite sign. So if this was positive, this one has to be negative. This one's positive, this one's negative. Positive, negative, positive, negative. We also saw that the steeper the gradient of the one line, the less steep the gradient of the other line. So this has got 2. This is negative 0.5. This one, let's go to high one 5, this is negative 0.2. So if we just compare the red with the black, you can see that the black line, that's the negative gradient, is a lot less steep than the negative gradient of the red line. And that makes sense because if you think about it, if we look at the red line is here, if I were to rotate this, I suppose, to the black line, I'd have to rotate that down there like that, and so we would get a less steep black line over here. So that bit is to be expected, but next is to actually identify the pattern, and it's easier to do that if we think about these as fractions. So 0.5 is the same as a half, 0.25 is the same as a quarter, 0.2 is the same as a fifth, and 0.3, this should be 0.3 recurring actually, and that is 1/3. A lot easier to identify the pattern then, because you might notice that I'll get a highlighter here. Yeah, like that. We've got a 2 here, and a 2 here, a 4 here, a 4 there, a 5, 5, and a 3, and a 3. So the gradient of the negative gradient is the gradient of the line that has a negative gradient is always -1 over the gradient of the first line. So the way that you can think about that is that the gradient of the perpendicular line is -1 divided by the gradient of the first line. So if we say that, so e.g. m in the first case is 2, and the gradient of the perpendicular line is -1 over 2. As you can see, that's what it is. So the phrase that we want to be using is, it's a negative because it's negative, of course, and it's 1 over the other value. We call that a reciprocal. So, for example, the reciprocal of 3 is 1/3. The negative reciprocal of 3 would be -1/3. Okay, but it works both ways. It's important to realize that we don't say this is the perpendicular gradient and this is the normal. That doesn't make any sense. It's more like this is the perpendicular gradient of that one, but also this is the perpendicular gradient of that one. So, in other words, if I let's say I just erase some of this. It's easy to see the first way around as I did it, but let's do it the other way around, just so we get a fuller understanding. If I said the normal gradient, I suppose, let's say the first line has got a gradient of -1/2, then the perpendicular gradient would be 1 over, or -1 over -1/2. I'm just going to write down here that, remember, the perpendicular gradient is equal to -1 over the regular gradient. So we can see that the negative symbols cancel out. 1 divided by 1/2, if you tap it into a calculator, is 2. So it works both ways. Okay. Yes, I think that pretty much sums it up. It's the negative reciprocal. I was going to say one other thing, but I can't remember what it was anymore. Yeah. Okay. Yeah. So that's basically parallel lines and perpendicular lines. Oh, okay. Just got to choose the right tool and